We have one more system to solve, and you can see the process is the same no matter how the solution turns out. I need to graph both lines by finding the slope and the y-intercept. So here is the latest system. This one of them is solved, one of them is not, just so that we can keep practicing. So the first one, remember the slope is always the number in front of the x, so that is, in this case, negative 2/3. Now, you might have a question that is pretty common. Mr. Perkins, that negative that's out in front, what do I do with it? Does it go with the 2 or does it go with the 3? And the answer is, pick one. It doesn't matter. So you can either do negative 2/3 or you can do 2/3. The thing not to do is do not say negative 2/3 because now, look what you've done. Negative divided by a negative is now a positive number. So you've changed the number. So that would be the wrong thing to do. So pick the numerator or the denominator and put your negative there. It really doesn't matter. The y-intercept of this graph is going to be this value right here, which is 1, so 0, 1. The second graph was given to us in what's called standard form. Doesn't matter if you know that or not, but I'm going to solve it for y. So I've got to get this y here all by itself, so that takes 2 steps. First step, I've got to subtract the 2x from both sides. If you watched the previous video, you've seen that we've already done that. And so I've got 3y is equal to negative 2x plus 3. And then I have a number in front of the y, so that's 3 times y. The opposite of multiplying by 3 is dividing by 3. Now, here is another common mistake that I want you to avoid. The distributive property applies to division just like it does to multiplication. So you have to take this 3 and you have to distribute it into both terms. So what that means is the first term is negative 2/3 x. Again, this negative, when we find the slope, can either go with the 2 or the 3, it doesn't matter. And then 3/3, well, your calculator will tell you that 3/3 is just 1. And so that means, again, my slope is negative 2/3. I'm going to leave the negative with the top. And then my y-intercept is 0, 1. Notice we have the same information for both graphs. So I'm going to graph this, and then I'm going to tell you what that means about your solution. So here we go. The first graph, the top one that we saw, said that it had a y-intercept of 1. So up here, I'm going to make a nice pink dot. And then the slope was negative 2/3. I'm going to graph this with the negative in both areas just to show you that it doesn't matter. If I put the negative with the 2, so negative 2/3, negative 2 would mean go down 2, 1, 2, and then positive 3 would mean go right 3, 1, 2, 3. Down 2, right 3. Now I'm going to go back to my y-intercept, and let's say that you were somebody that put the negative with the bottom. That's fine. That means you have 2/3. So the 2 means go up 2, and then the 3 means go left 3. Notice all of these points line up, so it doesn't matter where you put the negative, if you put it with the top of this or if you put it with the bottom of this. So now I'm going to connect these very lovely pink dots that we have. And, oh, that's beautiful line. Love it. The second equation had the same slope and y-intercept. I'm going to graph it just to show you. So again, the y-intercept was 1. And then I had negative 2/3. So down 2, right 3. And you can see, just like we would expect, all the dots are lining up. But what this means is that these two lines, since they overlap, they intersect everywhere, okay? They intersect on every point on the line, okay? So what we have in this situation, and I'm going to try to write this neatly for you because it's important, what we have is the same line, okay? This mathematically is what's called a dependent system. And since the lines are on top of each other, the lines intersect. Uh-oh, my pen is not behaving. There we go. My lines intersect everywhere. And so that means the solution, and this is what you will write down, this is what Mrs. Perkins is going to want to see, the solution is every point on the line. And you could see that when we were graphing. I go down 2 over 3, and I kept intersecting with my line everywhere.